A slant asymptote occurs anytime the degree of the numerator is exactly one higher than the degree of the denominator. So that means anytime your degree on top is one higher, you have a slant asymptote. For simplicity's sake, we are only going to deal with quadratics on top, but just know that technically it can occur in other situations. How do you find a slant asymptote? You're going to have to use long division. And so you may want to watch this video for some examples and steps on how to do long division. We're going to go through 3 examples, and in the last 2 examples we will graph the slant asymptotes. All right, example 1, determine the slant asymptote. Okay, so that means I have a squared on top, and this is x to the 1 power. Anytime you don't see an exponent, it's implied to be a 1. So 2 is exactly 1 more than 1. So that means we do have a slant asymptote. And how do we find it? Do long division. Okay, x times what is going to give me negative 3x squared? Distribute your negative 3. Change the signs and add, which is the same thing as subtracting. And then bring down your unused term. Okay, now we're going to repeat the process. X times what gives me 11x? 11. So distribute your 11. And now subtract, which is the same thing as changing the signs and adding. Okay, we don't actually care what our remainder is in this case. All we care about is the quotient, the number on top, the equation on top is our slant asymptote, y equals. Okay, so that's it. You just do long division, and whatever your quotient is, whatever your answer is, set y equals this line here is my slant asymptote. Who cares what my remainder is? I only care about what's on top. Let's do 2 more examples. Find the slant asymptote. All right, we're going to do long division. Side note, we could have done synthetic division on that last example because there wasn't a number in front and this was a 1 power. But I am definitely going to give you some examples like this where there are numbers in front of your x, and so you cannot do synthetic division here. In order for you to get a correct answer, you need to do long division. All right, 5x times what is going to give me 20x squared? Well, 5 times 4 is 20, and x times x is x squared. All right, distribute your 4x. And now subtract, which is the same thing as changing your signs and adding. Bring down your unused terms and repeat. So now 5x times what gives me 5x? Well, 5x times 1. Distribute your 1, and then subtract, which is the same thing as changing your signs and adding straight down. This is my remainder, but I don't really care what that is, so my slant asymptote is y equals 4x plus 1. That is my equation. If you were asked to graph your asymptotes here in this problem, I would use a dotted line and I would graph, remember, y equals mx plus b. This constant number here is your b, or your y-intercept. So positive 1. And then my slope here is 4. I can turn it into a fraction by writing it over 1. And that tells me I'm going to go up 4 and forward 1. So up 1, 2, 3, 4, and forward 1 to get to my second point. And so this, you should probably use a ruler to make sure that your line is drawn straight. But you have the general idea. That is my slant asymptote. If I also wanted to graph my vertical asymptote, remember your vertical asymptote is the denominator. This top part doesn't factor, so that means I'm not going to have any holes. So that means this is for sure my vertical asymptote. It's not a hole. And so that would be negative 2/5. So that'd be somewhere like, fractions, right here, between 0 and 1. So if you do long division, you can find the equation for your slant asymptote, and then I can graph those two lines. My vertical asymptote, this should be a straight line up and down. My slant asymptote is this line that is defined by this equation here. All right, let's do one last example just for you to have another example. Determine the slant asymptote, so I'm going to do long division. All right, 7x times what is 21x squared? So I'll distribute. Subtract, which means change your signs, and bring down your unused terms. All right, 7x times what is 14x? Distribute. Subtract, which means change your signs, and add. So my slant asymptote is y equals 3x plus 2. If I wanted to graph that, I would graph that 2 is my y-intercept, and then I need to go up 3 and forward 1 to get to my second coordinate point. So that would be my slant asymptote, and I could graph my vertical asymptote. This doesn't factor, so my vertical asymptote would be at x equals 1/7, which would be right here, roughly.